Hello people and welcome back to Maybe Ismail. This is part 2 of quadratic equations and I would recommend to watch that video if you haven't watched it yet so that it would be a continuation and it would be helpful for you. Okay, so in this session we will be discussing about the quadratic formula and we will look at a few questions that are based on the quadratic formulas. Okay, so let us start with the very basic, that what does a quadratic equation look like? So it looks like ax square plus bx plus c is equal to 0. Now, in order to solve this quadratic equation, we have two methods. We either do it by factorization or we do it by the formula method. Okay. Now, we discussed about the factorization method and all those things in the part 1 video, and now we'll be discussing about the quadratic formula. So, the quadratic formula says that the value of x, that is the solution for this equation, would be minus b plus or minus root of b square minus 4ac upon 2a. So it is minus b plus or minus root of b square minus 4ac upon 2a. Okay, so this is the formula. And if we look at the formula, a, b and c are basically the coefficients of x square, x and the constant term respectively. Okay, we just need to take those values, plug it in over here, and that is it. Okay, now the thing is, the square root part, the b square minus 4ac, that holds a good importance in this chapter. Okay, now that b square minus 4ac could either be positive, it could either be negative, or it could be 0. Okay, and this thing, the b square minus 4ac is known as the discriminant. Okay, and it is represented by capital D. Okay, now what if b square minus 4ac is greater than 0? So if b square minus 4ac is greater than 0, I will have real and distinct roots. Real and distinct roots. What do I mean by this? By this I mean that when I solve the quadratic equation, I'll get two different values of x. Okay, what does it signify? It signifies a very basic thing, that a quadratic equation, any quadratic equation, just gives us a parabola. That's the graph of a quadratic equation. Okay, if I have real and distinct roots, the parabola that I'm gonna get will intersect the x-axis at two separate positions. Okay, and those are the two values of x. Now it could be anything. I've just drawn a basic graph. The graph could move anywhere. Okay, so that's the first part. The second part is that b square minus 4ac could be equal to 0. When this happens, I get real and equal roots, or real and repeated roots. Okay, now what does this mean? This signifies that the parabola, the same exact thing, obviously it's a quadratic equation, I'll be getting a parabola as my graph. This parabola will intersect the x-axis only at one specific point, okay, which is the vertex of the parabola. Okay, so it won't be two different points, it would be just one point, which is the vertex of the parabola that would intersect the x-axis. And lastly, if we have b square minus 4ac to be less than 0, so b square minus 4ac would be less than 0, I will have no real roots, or I can say I have imaginary roots. I will have imaginary roots. Now what does this signify? This signifies that there won't be any roots to this kind of a quadratic equation. So how would the graph look like? It would be a very basic graph, a parabola obviously, but it will not cut the x-axis. It will not intersect the x-axis anywhere. Okay, so hence there won't be any roots. There won't be any values of x because it does not intersect the x-axis, and it is as simple as that. Okay, now based on this much of information, there could be tons of questions that could be made. The simplest one, obviously, to solve a quadratic equation using the quadratic formula, and the other ones would be to figuring out the nature of roots, if the parabola is going to intersect the x-axis, if it is not going to intersect the x-axis, what are those kind of things could be. So that's what the entirety of this formula signifies. Okay, so let us move ahead with solving a few kind of questions. So the first type of question would definitely be to solve quadratic equations based on this formula. Okay, so I have a question which is like x square minus 8x plus 5 is equal to 0. That's the question, and the question simply says that solve the quadratic equation with the quadratic formula. It is either this thing, or it could just, like in the exam, it would be solve the quadratic equations. So you could solve it by the factorization method, or you could do it by the quadratic formula. The fact is, not all questions can be solved by factorization method, but every single question can surely be solved by the quadratic formula. Okay, I look at this equation and I try to figure out the values of a, b and c because that is what is needed in the quadratic equation. Now the standard form is ax square plus bx plus c is equal to 0. Hence a is the coefficient of x square, no coefficient, which means the coefficient is 1 over here. B is the coefficient of x, it would be negative 8, and c is the constant term, which is 5. Now I write my formula which says x is equal to minus b plus or minus root of b square minus 4ac upon 2a. Okay, that's the formula. I just need to plug in my values in the formula. So x is equal to negative b. So it would be minus of minus 8, which is plus 8, plus or minus root of b square, which is negative 8 squared, minus 4 times a, which is 1, times c, which is just 5. Okay, divided by 2a. So it would be 2 times 1. So this would be 8 plus or minus square root of 8 square is 64 minus 4 times 1 times 5 is just 20 upon 2 times 1 is just 2. So this would be 8 plus or minus square root of 44 upon 2. Now this thing can be simplified as 8 plus or minus square root of 44 can be written as 4 times 11. Because I know the square root of 4 already, so I can pull it out and simplify my equation. So it becomes 8 plus or minus 2 root 11, the whole thing upon 2. But the 2 in the denominator can go with both the terms in the numerator. So it becomes 4 plus or minus root of 11. That is the value of x. Now how do I simplify this thing? To do this, I would just split it up into two parts and I would say x is either 4 plus square root of 11 or x is 4 minus square root of 11. 4 minus square root of 11. Now the fact is square root of 11 you could turn up with knowing the value of the square root of whatever the number is. It could be like square root of 3. So we know square root of 3 is 1.73. Square root of 2 is 1.414, but square root of 11 or maybe square root of 10, 3.162, but square root of 11 is not known to us. Either it would be given to you in the question or you'd be using the tables to figure out the value of the square root. Right now I don't have the table, so I'll just use my calculator to figure out the square root of 11. Yeah, I have this calculator, the CG100 Casio. Okay, so square root of 11 is 3.316. Okay, so it would be x is equal to 4 plus 3.316 or x is equal to 4 minus 3.316. Okay, so x is either 7.316 or x would be equal to 0.683. Those are the two values. Now the question could also be give the answer in 3 significant figures, 2 significant figures, or 2 decimal places. You have to report your answer according to whatever is being asked in the question, the significant figures or the decimal places. If nothing is asked, just prefer writing like 3 decimal places. That's the best way to keep. Okay, I hope that is like a very easy question for everybody. Let's try another question of a similar kind. Okay, so let's say I have a question which says 4x plus 6 over x plus 13 is equal to 0. Now this surely does not look like a quadratic equation, but I have an x in the denominator. To get rid of that x, I would just multiply the entire equation by x. So my equation now becomes 4x square plus 6x plus 4x square plus 6 plus 13x is equal to 0. If I rearrange the equation, because I have to rearrange it, I have to keep it in the standard form. So it would become 4x square plus 13x plus 6 is equal to 0. Now I can figure out the value of a, b and c. So a would be 4, b is 13 and c is the constant term, which is 6. I write my formula, which is x is equal to minus b plus or minus root of b square minus 4ac upon 2a. When I plug in the values of a, b and c, it would become x is equal to negative b, so negative 13 plus or minus square root of b square, which is 13 square, is 169 minus 4ac. So 4 into 4, 16. 16 times 6. So 16 times 6 is, 16 times 6 is 96. So minus 96 divided by 2a, which means 2 times 4, which is just 8. Okay. So this becomes negative 13 plus or minus square root of 169 minus 96. 169 minus 96 is 73 divided by 8. Now I can't factor out anything from the 73 and like bring it out of the root. So I just either keep my answer like this and like these are my two answers, or I could figure out the square root of 73. So the square root of 73 is 8.544. So I can definitely say that my answer for x would be negative 13 plus or minus 8.544, the whole thing upon 8. So once I will take the positive sign of it, so x1 I would say would be negative 13 plus 8.544 upon 8, and when I simplify this thing I get some answer, and x2 would be negative 13 minus 8.544 upon 8, and when I simplify this thing I get some other answer. I'm just not doing it, you can do it on your own. So that is how you find the two answers with the help of a quadratic equation formula. Okay, yeah, let us move ahead to the next kind of question, which is also a similar one, but we just have to simplify it and bring it into the standard form. So it is x minus 1 all squared minus 3x plus 4 is equal to 0. Now I can see that there is an expansion thing in the first term. So a minus b the whole square is a square minus 2ab plus b square, and then the minus 3x plus 4 remains as it is equal to 0. So this in turn becomes x square minus 2x minus 3x is minus 5x, and 1 plus 4 is a 5, so plus 5 is equal to 0. In this one I say a is 1, b is negative 5, and c is 5. Okay, now I have the value of a, b and c. Just plug it into the formula and figure out your answer. I won't be doing this thing. You can tell me the answers in the comments. Okay, let us move ahead to the next question, next type of question I would say. Okay, the next question says that find the nature of roots of the given quadratic equations. Okay, so I have a quadratic equation which is 7x square minus 9x plus 2 is equal to 0. The question does not ask me to solve the quadratic equation. It just says find the nature of the roots. Would it be real? Would it be imaginary? If it is real, then how would it be? So I just write the values of a, b and c first. So a is 7, b is negative 9, and c is 2. So these are the three values that I have, a, b and c. Now, in order to find the nature of root, I don't need the entire formula. I just need the value of b square minus 4ac. So I say fair enough. So b square minus 4ac. This thing would be equal to b square. So negative 9 square minus 4 times a, which is 7, times c, which is 2. So negative 9 squared is 81 minus 4 times 7 is 28. 28 times 2 is 56. I'm just not bothered about subtracting this. I surely know whatever the answer is, it's going to be greater than 0. Okay, now if the answer is greater than 0, so I'll say therefore the roots are real and distinct. So I have real and distinct roots. Okay, I would not recommend you to keep this space empty, just fill it up. I'm just not doing it. Okay, next I have the same exact kind of question, which is x square plus 2 root 3x plus 9 is equal to 0. Again, the same question, what is the nature of roots? Again, I'd say that a is equal to 1, b is equal to 2 root 3, and c is equal to 9. I have to find what b square minus 4ac is. So b square minus 4ac would be b square. So 2 root 3 square minus 4 times a, which is 1, times c, which is 9. Okay, so the square goes to both of them, to the 2 and the root 3. So 2 square is 4, root 3 square is 3, minus 4 times 9 is 36. So 4 3s are 12 minus 36, that is negative 24, which is less than 0. If b square minus 4ac is less than 0, I will have no real roots, or I can say imaginary roots. I'll have imaginary roots. I know my handwriting is very good, sorry for that, guys. Okay, so that is what it is imaginary roots. Let us move ahead to another question, same kind of question. So it is 25x square minus 10x plus 1 is equal to 0. A would be 25, b is negative 10, and c is 1. Again, I need b square minus 4ac. So b square minus 4ac would be equal to negative 10 squared minus 4 times a, which is 25, times c, which is just 1. So negative 10 square is 100 minus 4 times 25 is also 100, and this is 0, and 0 means that the roots are real and equal. So real and equal roots. Okay, fine. Let us move so we did two kind of questions. One was basically solving a quadratic equation with the help of the formula, and the second was to find the nature of roots with the help of the formula, basically a part of a formula, which is b square minus 4ac. The third kind of questions would be to find the value of an unknown in the equation if the nature of the root is given to us. Okay, so let's look at a question. So this question says that if 3x square minus 12x plus n minus 5 is equal to 0, this thing has equal roots. Okay, so this thing has equal roots. Okay, what is the value of n? If it has equal roots, what's the value of n? I just try to use the simple formula, which is b square minus 4ac has to be equal to 0 if the nature of roots is equal. Okay, let's see what a, b and c is. A is the coefficient of x square, which is 3, b is the coefficient of x, which is negative 12, and c is the constant term. So over here the constant term is n minus 5. That's the value of c. Now since it has equal roots, I'll say b square minus 4ac should be equal to 0 because it has equal roots, which means b square would be equal to 4ac. Now what's b square? It is negative 12 squared is equal to 4 times a, which is 3, times c, which is n minus 5. Okay, negative 12 square is 144 is equal to 4 times 3 is 12 times n minus 5. I would not prefer opening up the bracket. I would cancel out this thing. So 12 times 1 and 12 times 12. So 12 is equal to n minus 5. I send the 5 to the other side, side change, sign change. N is equal to 12 plus 5. Hence n would be equal to 17. Very, very easy. Next question. Similar kind of question. So the question is m minus 2 times x square minus 5 plus m times x plus 16 is equal to 0. And it also says that the roots are equal. So it has equal roots, and I need to figure out the value of m. Okay, same procedure, exactly the same thing. Let's see what a is. A is the coefficient of x square, so here it would be m minus 2. B is the coefficient of x, so b would be negative 5 plus m. Do not forget the negative sign. And c is the constant term, which is 16 over here. Since it has equal roots, I would say b square minus 4ac has to be equal to 0. So b square minus 4ac would be equal to 0, which means that b square would be equal to 4ac. B square, which means negative 5 plus m, and all of that squared is equal to 4 times a, which is m minus 2, times c, which is 16. Okay, now if I have a square and that thing itself is negative, I can just ignore the negative sign because the square of a negative thing is also positive. Okay, so I just ignore the sign and I just expand it as a plus b the whole square. So a plus b the whole square is a square, so 25, plus 2ab, so 2 times 5 times m, so 10m, plus b square, so it would be m square, is equal to 4, and this 16 gets multiplied to a 64, and then m minus 2. Simplifying this thing, so it becomes m square plus 10m plus 25 is equal to 64m minus 128. Sending these two things to the other side, so it becomes m square plus 10m minus 64m would be minus 54m, and 25 plus 128 would be 153 is equal to 0. Okay, now that's a quadratic equation, that is like another quadratic equation while solving the value of m. Okay, I can clearly see that this thing can be done by factorization, and it is 51 times 3. 51 times 3 is 153, and 51 plus 3 is 54. So this would be m square minus 51m minus 3m plus 153 is equal to 0. I can take an m common, so it would be m minus 51 minus 3 common, and it would be again m minus 51, which is equal to 0. Hence m minus 51 times m minus 3 is equal to 0. From here I can say that m is either equal to 51 or m is equal to 3. Those are my two values of m which were required from this question. Okay. Let us move ahead to same exact question, but this time it won't be equal roots. So I'll have to use a different condition for it. Okay. So the question is 3x square minus 6x plus k is equal to 0. And it says it has distinct roots. Distinct roots. So if the question says that this thing has distinct roots, which surely means that b square minus 4ac has to be greater than 0. Okay. So b square minus 4ac has to be greater than 0. B square, oh, I didn't write the values of a, b and c. So over here a would be 3, b would be negative 6 and c would be k. Okay. So b square, which means negative 6 squared minus 4 times a, which is 3, times c, which is just k, has to be greater than 0. Negative 6 square is 36 minus 4 times 3 is 12k, greater than 0. I send the 12k to the other side. So 36 has to be greater than 12k. 12 times 1 and 12 times 3. Hence k has to be less than 3. That is my final answer. So it could either be equal roots, then it is b square minus 4ac equal to 0, or greater than 0 when it is distinct roots. And even if it says imaginary roots, you use the same method but use b square minus 4ac less than 0. I don't have a question for that, but yeah, this is what it is. Let us move ahead to the next question. And the questions is basically like these are kind of miscellaneous questions which we all need to know how to do it. Based on the formula, we did a few questions and those are what could be done. Now the questions that I'm going to do can be done by the formula, can be done by factorization, whatever you feel like, but these are just miscellaneous kind of questions. Let us look at the questions. So the first one which I have over here is 2x raised to 4 minus 5x square plus 3 is equal to 0. If I look very carefully in this question, the equation does not look like a quadratic equation, and the reason for that is the power of x. The power of x over here is 4, and in a quadratic equation we need the power of x to be equal to 2, which does not hold true in this question. What I can do is I can say let x square be equal to y. Okay. So if I let x square to be equal to y, my question would turn out to be y square, I mean 2y square minus 5y plus 3 is equal to 0, because I have replaced all the x squares with a y, and x raised to 4 is actually x square ka squared. Okay. This surely looks like a quadratic equation, and it looks like a very basic quadratic equation which probably can be solved by factorization also. So the product over here is 6. Product is the first number times the last number, so it is 6, and the sum or the difference is negative 5. Okay, let us solve this. What are two numbers that multiply to 6? So it is 2 times 3. Sure, 2 times 3 is 6. What else? I need a negative 5, which means it has to be negative 2, negative 3. So negative 2 times negative 3 is still going to give me a positive 6. So those are my numbers. So it would be 2y square minus 2y minus 3y plus 3 is equal to 0. I can factor out a 2 and a y from here. So it becomes y minus 1. I can factor out a 3 from here. It becomes y minus 1 is equal to 0. So this would be y minus 1 times 2y minus 3 is equal to 0, which means y would be equal to 1 or y would be equal to 3 over 2. Those are the two values of y, but the fact is nobody asked us what the value of y is in the question. We've been asked the value of x. So what I do is I go back to my question from where I started, and since I got the value of y to be equal to 1, I can say y is equal to 1, which means x square is equal to 1, because I just said that let x square be y. And also I got y to be equal to 3 over 2, which means x square itself is equal to 3 over 2. Okay. So over here, if x square is 1, x would be square root of 1, but I can't leave it that way. I'll have to say it is a plus and a minus. Okay. Which means x is equal to plus or minus 1. Same thing over here, x square is 3 over 2. So x would be equal to square root of 3 over 2. Obviously I can't leave it that way. So I'll say positive and negative both. So those are the four answers. So x is either plus or minus 1, or it is plus or minus root of 3 over 2. These are the four answers. Was I expecting 4 answers? Surely I was expecting 4 answers, and the reason behind that is the power of x. If the highest power is 4, I will expect 4 answers. Like in quadratic equations we expect 2 answers, linear equations we expect 1 answer. Okay, let us move ahead to another kind of question. Okay, so this question which I have over here is x square minus x all squared plus 5 times x square minus x plus 4 is equal to 0. Now, the simple way of doing this question is to again let something to be some better thing and do it. And the not very simple way is to use the expansion formula, which is a minus b the whole square, and do it. I would not recommend doing that. That's just a waste of time. Okay. So I would say let x square minus x be equal to y. Why do I say that? Because I see it is being repeated multiple times over here. And we can just take help of this thing. So if x square minus x itself is y, my equation becomes y square plus 5y plus 4 is equal to 0. Now the product is 4 and the sum of the difference is the middle number, which is 5. So 4 times 1 is 4. So I can directly write y square plus 4y plus y plus 4 is equal to 0. Factor out a y, so it becomes y plus 4. From the second two, nothing is common, which means 1 is common. So y plus 4 is equal to 0. That would be y plus 4 times y plus 1, which is equal to 0, which means y is equal to negative 4 or y is equal to negative 1. Those are the two values of y that I get. But nobody asks us what the value of y is, because y does not exist in the question, which means I'll have to get back to the substitution part. I'll have to resubstitute the value of y as x square minus x. So I'll say therefore x square minus x would be equal to negative 4, or x square minus x would be equal to negative 1. When I simplify this thing, it becomes x square minus x plus 4 is equal to 0, or x square minus x plus 1 is equal to 0. Now these are two separate equations and I need to solve them separately to get the values of x. So from here also I'll get two separate values of x from both the equations, so total 4 values. Let us try to solve it. Now when I look at this thing, I realize that the first equation, I can't do it by factorization method. And when I try to figure out b square minus 4ac, for this thing b square minus 4ac would be less than 0. Same thing, b square minus 4ac would be less than 0. So for both of them, b square minus 4ac would be less than 0. And we won't have any real values of x for this particular question. No real values of x. Just for the gist of it, I'm explaining what the graph of this thing would look like. I don't know the exact position of the graph, but the nature of the graph can be explained very easily. It would be like this. It's a W shape, and it will not intersect the x-axis at any point. And had it been a real root kind of thing, it would have been a W, but it would intersect the x-axis at 1, 2, 3, and 4 points. But right now it is not intersecting the x-axis, so it has no real root. So that is how the graph is going to look like. Okay. And you should not be afraid of these kind of questions. Like if you don't get a definite answer to it, you can surely report your answer and say that there are no real roots for this kind of equation. Simple, just move ahead with that. Okay, let us move ahead to the next question. Okay, so my question is 3x plus 1 upon x plus 1 plus x plus 1 upon 3x plus 1 is equal to 5 over 2. Okay, there are again two ways of doing it. First is that you just cross multiply the fractions and then do all the silly stuff. The second way is to assume it to be something. Okay, and the fun fact is that this thing is something and this thing is just the reciprocal of it. So if I say let 3x plus 1 upon x plus 1 is equal to y. So the first part of the thing, the first term is going to be y. So I'll write y. Plus the second part is just the reciprocal, the flip of it. So I'll write 1 over y is equal to 5 over 2. That is how simple basic my equation looks like. Now I need to get rid of the denominators. So I'll have to multiply with a y to get rid of the y. I have to multiply it with a 2 to get rid of the 2. So just multiply it with 2y. So every term gets multiplied with 2y. So it becomes 2y square plus 2 is equal to 5y. Take everything to one side. So it becomes 2y square minus 5y plus 2 is equal to 0. That's a quadratic equation. 2 times 2 is 4, and negative 4 times negative 1 is also 4, and negative 4 minus 1 adds up to negative 5. So 2y square minus 4y minus y plus 2 is equal to 0. Take a 2 and a y common, it would be y minus 2. Minus 1 is common, y minus 2 is equal to 0, which means y minus 2 times 2y minus 1 is equal to 0, which means y is equal to 2 or y is equal to 1 over 2. Those are the two values of y. And again, we are at the same position that nobody asked us in the question what is the value of y, because y does not exist. So I can come back to my question and say that therefore 3x plus 1 upon x plus 1 would be equal to 2, or 3x plus 1 upon x plus 1 would be equal to 1 over 2, because that is what I have assumed y to be. So y are two things, so these are two things. Send the x plus 1 to the other side, so it becomes 3x plus 1 is equal to 2x plus 2. All the x's on one side, everything that does not have an x to the other side. 3x minus 2x is equal to 2 minus 1. So x would be equal to 1. That is one of the values of x that I got. For the other value, I'll just solve this part. So 2 goes to the other side, so 6x plus 2, x plus 1 goes to the other side, remains as it is. All the x's on one side, so 6x minus x is equal to non-x's on the other side. 6x minus x is 5x is equal to 1 minus 2 is a negative 1. Hence, x would be equal to negative 1 over 5. Those are the required answers, the two values of x, 1 and negative 1 over 5. Okay, next question. So the next question is x square plus 5x plus 4 times x square plus 5x plus 6, and that is equal to 120. That's a very strange question, okay, but it is not actually very strange. If you observe a pattern, if you see very closely, x square plus 5x and x square plus 5x is a thing which is being repeated, so I can just assume that to be something. So let x square plus 5x be equal to y. X square plus 5x equal to y. Just substitute x square plus 5x as y. So my equation now becomes y plus 4 times y plus 6 is equal to 120. Open up the brackets. Y goes to both of them, so y square plus 6y. 4 goes to both of them, so 4y plus 24 is equal to 120. So this becomes y square plus 10y. 24 minus 120 is negative 96 is equal to 0. Negative 96. Let me think of two numbers that give me negative 96. 12 times 8 is that 96. Okay. We need to solve this equation. 96. Okay, let me just do it on the calculator. I'm not able to think about it. Okay, so it is 1, 10 and negative 96. Okay, so it is 6 and 16. Okay, so y square plus 16y minus 6y minus 96 is equal to 0. I take a y common, it would be y plus 16, a negative 6 common, it would be y plus 16 is equal to 0. So that would be y plus 16 times y minus 6 is equal to 0. And from here I'll get y is equal to negative 16 and I'll get y is equal to 6. But again, we are at the same page that nobody asked the value of y, which means we need to get back to the substitution part. And now we'll say y is equal to 16, which means x square plus 5x is equal to negative 16, which means x square plus 5x plus 16 is equal to 0. Okay, now if I look at this equation, I kind of realize that b square minus 4ac would be less than 0, because b square is 5 square minus 4 times a times c. So 5 square is 25 minus 16 times 4 is 64. So that would be less than 0. So from here, I will not get any values of x, which means I'll have to use x square plus 5x is equal to the other thing, which is 6. So I'll say x square plus 5x is equal to 6. Send the 6 to the other side. So x square plus 5x minus 6 is equal to 0. 6 times 1 is 6 and 3 times 2 is 6. The product is negative 6 and this thing is 1. So I'll probably use x square plus 6x minus x minus 6 is equal to 0. So I'll take x and then it would be x plus 6. I take a minus 1. It would be x plus 6 is equal to 0. So that would be x plus 6 times x minus 1 is equal to 0, which means x is equal to negative 6. or x is equal to 1. So these are the two values of x that I surely needed. From the first equation, I get no values of x. From the second equation, I do get two values of x. Okay, let us move ahead to the last question of this video. The question is 5 raised to x plus 1 plus 5 raised to 2 minus x is equal to 5 cube plus 1. This is not a very straightforward question, and it's like not a very direct kind of question. We need to work it out. Okay, now we should know the laws of indices to do this, like when bases are same, powers get added, and when bases are same, powers get subtracted. What do I mean by that? It is a raised to m times a raised to n. This thing can be written as a raised to m plus n, and a raised to m upon a raised to n can be written as a raised to m minus n. We just need to know these two things. Okay, so if I see it is 5 raised to x plus 1, which means I can assume that there was a 5 raised to x which was being multiplied with a 5 raised to 1, and hence when bases were same, the powers got added. So I can say it is actually 5 raised to x times 5 raised to 1 plus same thing over here, 5 raised to 2 upon 5 raised to x. Okay, I just assume that it was like that. That is why it looks like this. So I just undo the thing. Is equal to 5 cube is 125 plus 1. Okay, fair enough. Looks really good to me. I can say this is 5 times 5 raised to x plus 25 upon 5 raised to x is equal to 126. I can see that the 5 raised to x can be substituted and this thing can be simplified. So I'll say, okay, let 5 raised to x is equal to y. So now my equation would look like 5y plus 25 upon y is equal to 126. I multiply the entire equation by y. So now this becomes 5y square plus 25 is equal to 126y. Send the 126 to the other side, so it becomes 5y square minus 126y plus 25 is equal to 0. So the product is 5 times 25, which is 125, and 125 times 1 is 125. So I can say 5y square minus 125y minus y plus 25 is equal to 0. Okay, so this thing would be 5y and it would be y minus 25. I take a minus 1 common, it would be y minus 25 is equal to 0. I'll just continue it over here. This is equal to 0. Okay, so this would be y minus 25 times 5y minus 1, which is equal to 0. From here I can say that y is either equal to 25 or y is equal to 1 over 5. But the fact is nobody asked us about y, and we can resubstitute the value of y as 5 raised to x. So I can say 5 raised to x is equal to 25, or I can say 5 raised to x is 1 over 5. I can convert the 25 and 1 over 25 1 over 5 to exponents. So it becomes 5 raised to x is 5 raised to 2, because 5 square is 25. From here I can compare the two sides and say that x would be equal to 2. That is one of the values. Over here on the other side I can say 5 raised to x would be equal to 5 raised to negative 1, because it is an inverse of it, and hence I can say x would be equal to negative 1, and that is my answer. Okay, I hope you all found this video helpful. I would have to give you one question as homework maybe or something. Let's see. So this question is 1 over p plus 1 over q plus 1 over x is equal to 1 over p plus q plus x. Okay, I want you all to try doing this question by any method that you feel like. Okay, that's a very easy question to do. Just the fact is that you need to know the trick you need to know the start point of this question. And if you're able to solve this question, just comment down the answers to this thing. It is also present in one of the national textbooks. So yeah, I hope this thing was helpful to you all. Thank you so much. Please do share these videos with your friends so that it could help them also. Thank you so much for watching. Bye bye.